Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving an equation. We have z plus I equals z over I. So we're basically looking for a complex number such that when we add I to it or when we divide by I, we get the same answer. So I'll be presenting a couple different approaches or methods for this problem. So bear with me while I go through the very first method. Okay. The very first method is basically going to involve cross multiplication first. Let's go ahead and multiply z plus I by I. So it's going to be zi plus I squared equals z. And then I squared is -1, so I'm going to write it as zi minus 1 is equal to z. And now, since z is a complex number, I can just replace it with something like a plus bi, right? Does that look familiar? Z equals a plus bi. If you replace z with a plus bi, then you get I times a plus bi minus 1 equals a plus bi. And of course, we can solve for a and b, can't we? Let's go ahead and distribute first. ai, not artificial intelligence, just ai, plus bi squared, which is minus b. Remember, I squared is -1, right? Minus 1 equals a plus bi. Let's arrange these terms a little bit so that real part and the imaginary part are separated. And now we can compare the real parts and the imaginary parts. Think about it. Real part here is a, so this must be a. And a is b, so a must be b. B must be a must be b. What does that mean? It means that we have a system of equations. -b minus 1 is equal to a, or a is equal to b. But since a is b, we can replace a with b and now solve for b from here. Easy, right? So put the b's on the same side. You get 2b equals, or not 2b, yay. I got to make this joke once in a while. And now from here, b becomes -1/2. But since a and b are equal, we can also say a is -1/2. But guess what? That gives us the number we're looking for. Z was written as a plus bi, so it's going to be -1/2 plus -1/2 I, or we can write it as -1/2 or -1/2 I. So that would be the answer, right? I mean, if you want to go ahead and plug it in, you can do so, be my guest, but I'm just going to leave it at that because I'm lazy. Okay, so that's the first method, and it's a little long, but let's go ahead and take a look at an alternative approach, which I think you'll like better. Okay, so what do we have? We have z plus I equals z over I. So what can we do? We can still cross multiply, right? And when we do, we're going to get the same thing. Zi plus I squared is z, and then zi minus 1 is equal to z. Instead of now replacing z with a plus bi, because we have z's on both sides, let's go ahead and put the z's together, right? Kind of sounds, I know some people say z, but it's actually z, not z. Anyways, that's a different story. Now let's go ahead and put these together. Zi minus z equals 1. Let's just keep the 1 positive for now. Then we get a non-standard number, but that's okay. We can handle it. And then now we're going to factor out the z and then solve for z, of course. So we are supposed to divide both sides by I minus 1, and that will be the answer. But come on, you need to get rid of the I at the bottom. But let's go ahead and write it this way first. 1 over -1 plus I. Because what is the complex conjugate of I minus 1? Is it I plus 1? Yes and no. Well, I plus 1 works, but the problem is when you add those conjugates, they're not going to give you a real number. So that's the definition for complex conjugate is unique, and that should give you that. So the conjugate would be -1 minus I, -1 minus I. And remember, we always get sum of 2 squares at the bottom. We don't care if the numbers are negative or positive. Think about it this way. 1 squared plus 1 squared. It's what? 2, right? That's just going to be a 2 there. Great. And the numerator is just going to be -1 minus I. But this can be written as -1/2 minus 1/2 of I as before, right? Great. So obviously it will be the same answer. There's also still another alternative. Let me quickly mention that. I guess we could call this third method if you want. But here's how it works. We can go ahead and subtract z from both sides, and we would be getting this. And then I would make a common denominator, z minus zi over I equals I. And then I can factor out as z, 1 minus I, and then of course, I times I is just going to be I squared, which is negative 1. And then from here, z is going to be negative 1 over 1 minus I. And then we can do the same conjugate thingy, and we would be getting the exact same answer as before, because 2 is going to be at the bottom, and the numerator is just going to be the same. Negative 1 minus I divided by 2, or negative 1/2 minus 1/2 of I. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.